Hi there. In this video, we'll take a look at problem 3, in which we need to figure out if the diagram we're given has congruent triangles or not. So let's take a look. Using the given information, we're supposed to determine whether or not you can prove that the triangles are congruent. And if you can, we're supposed to write a congruent statement showing how the triangles are congruent. And it says to state which triangle congruence criteria supports your answer, whether it's SAS or SSS or ASA. Okay, and it says if not, explain why you cannot. Typically that would be because we're given a bunch of angles or because we're given the swinging door case, which is SSA. Okay, so with that, let's take a look at part A. Okay, in this problem, we're given two facts. Firstly, that AB is congruent to CD. And so we should make this information visual by placing a tick mark on those sides. Second, we're given the fact that angle B is congruent to angle D. So we'll mark angle B with a tick mark and angle D with a tick mark, making that information visual. The third thing to notice here is that these two triangles are sort of glued together, and in particular they share side AC, and so we'll make that observation visual by placing an X on the diagram. Putting it all together, we have that this side matches this side, this angle matches this angle, and this side is common to both triangles. So now we have to determine whether or not the two triangles are congruent. Let's take a look. We're given side, side angle, which matches side, side angle. Notice this is not the SAS case because the angle that's given is not included between the two sides, so that's not applicable. Instead, we have the side-side angle case, and we know that this is the swinging door case, so the triangles might not be congruent. So I'll state my conclusion. The triangles may or may not be congruent. We can't tell. Alright, so that's the solution to part A. Part B gives us that RT is perpendicular to SV, and so we can infer that they meet at a right angle. So those are 90-degree angles. Second, we're given that RS is congruent to TV, so we can place a tick mark on those sides to show that. And lastly, it says U is the midpoint of RT. So if U is really the midpoint, then these segments here ought to be the same. And we make that visual using the tick marks. Let's put that information all together into the picture with the right angles, perpendicular lines, with RS matching TV, and with U being the midpoint of RT. And now we're in position to figure out if the triangles are congruent or not. Let's see what we know here. This again looks like side-side angle, matching side-side angle. But what's special about this problem is the angle is actually a right angle, and the triangles are right triangles. And so this situation is special. It is in fact the hypotenuse leg situation. So I'm going to go back. The hypotenuse matches the hypotenuse, and the leg matches the leg. So we can say that triangle RUS is congruent to triangle TUV by the hypotenuse leg criterion. Okay, let's take a look at part C. Here we're given that segment AB bisects angle CAD, CAD, and what that means is that it cuts that angle into two equal parts. We'll make that visual with the tick marks. Next, we're also given that segment AB bisects angle CBD, CBD. And so that's cutting this angle into two congruent parts as well. Okay, let's see if there's one more thing to learn. Again, I see that the two triangles are glued together and that they share side AB. So I'll make my little X to make that observation visual. Putting it all together into one diagram, we have that the segment bisects the angle at the top and the angle at the bottom, and the triangles are glued together. So we can state our conclusion that triangle ACB is congruent to triangle ADB. And let me go back and see why that's true. We're given angle, side, angle, matching, angle, side, angle. So this would be the ASA triangle congruence criterion that explains why they have to be congruent. Okay, let's wrap up with part D. We have that segment FH is the perpendicular bisector of EG. Let's take that in parts. First, it's perpendicular to EG. That means it forms a right angle with EG. Second, FH is the bisector of EG. So if it bisects EG, that means that it's cutting it into two equal parts. So we make that visual with the tick marks. And lastly, we see that this triangle is glued to this triangle, sharing this segment in common, and we'll place an X there to represent that. Let's put it all together. FH is perpendicular to EG and bisects EG, and the two triangles share this side right here. So now let's ask, are the triangles congruent? Let's see. Side, angle, side, matching, side, angle, side. And so yes, the two triangles must be congruent. Triangle FHE, FHE is indeed congruent to triangle FHG, FHG, and we know that by the side, angle, side, triangle congruence criterion. Okay, and that wraps it up with this problem. Hope you found that helpful. See you next time.